Thank you very much. Of course. Great, thank you. All right, I'll kick it off. You can put everything. All right, morning everyone. Welcome to MASQUE at IETF116. We have a pretty packed agenda today. Hopefully some time for a good discussion at the end. So not wasting any time. You all, having been here for a week, know how to use the tool and Meet Echo. But if you have any problems or anything, just reach out to your neighbors and maybe they'll help you out. This is the note well. I'm sure you've all seen this before. In case you haven't, text is too small to read here, as David likes to point out. But please do read it. In particular, note the IPR, requirements and the code of conduct here. Just be respectful and friendly to one another, and we should have a grand old time talking about proxies. As a reminder, again, the IETF116 does require all participants to be wearing a mask in the room unless you're actively eating or drinking. So please keep your mask on, and there should be no issues. Hopefully that's not a problem. Here's some links. You can also get them from the agenda page, a link to the on-site tool, the agenda and whatnot. Chat, however you want to choose to engage in the meeting. When you are, if you do want to bump into the queue, a reminder, if you're on site, please do actually use the on-site tool to join the queue so we can manage the queue amongst the people who are not fortunate enough to be here with us, and should hopefully simplify things. All right, so this is the agenda. We do have a note taker. Thank you very much for the people who volunteered. A couple individual drafts that we'll talk about because we've gotten through basically the core drafts that this group, set out to achieve. Thank you very much to all you mask enthusiasts for getting this stuff out the door. And then we'll have sort of an open discussion on advertisement and discovery at the end. Before kind of jumping into things, I'd like to pause briefly to see if anyone has any adjustments they'd like to make to the agenda. Going once, going twice. Great. If not, Tommy, you're up first. Yeah, I'll pull them up. I'm having technical difficulties with the internet, but
I can also try to. Cool. Thank you.
Yeah, can you do it? Right, Eric's gonna do it.
Great. Good morning, everyone. So I'll be talking about our quickware proxying draft, which we've talked about in this group many times, and it's something that we, I think, have recently discussed as part of the rechartering of what's in scope or not. So I'll first do a little recap of what it is, some of the recent changes that we've made and been testing implementation, and then kind of the one big elephant in the room that we still need to talk about. So next slide, please. All right, so as a recap, what we are trying to do with this quickware proxying is extend Connect UDP to give a little bit more information to optimize cases where the next hop is a quick server and not just any arbitrary UDP endpoint. So the behavior here is that the client communicates with the proxy to tell it information about the inner quick connection that's being forwarded, about the connection IDs of that quick connection. And it does this now using capsules. So it's able to send capsules on the stream while it's forwarding datagrams and give hints to the proxy. And so there are a couple different things that the proxy can do with this knowledge. One of these things is that it can start reusing the ports and essentially the sockets between the proxy and the quick server that is targeting because it is able to do connection ID based demultiplexing. But then the bigger thing, which in our implementations we found more useful, is the fact that you can optimize things to skip the extra encapsulation and encryption when you have proxied short header packets going through this. Mainly is like if you're thinking of chaining multiple mask proxies over quick together, it allows you to not have a cumulative encapsulation and lose MTU at every hop. Instead, since the wire image of the packets are, the interior packets and the outer packets are both just quick short header packets, you can essentially just forward rather than putting them inside extra datagrams. And one of the more recent changes we've done here is that these forwarded mode packets use virtual CIDs. And so this is very important to make sure that the proxy and client still get to choose the connection IDs that they use for packets between them. And then essentially it's like a connection ID NAT you can think of for forwarding packets. And so it swaps out IP addresses, UDP ports, and connection IDs, and then has the payload go beyond that. Next slide. So if we want a diagram at some point to come back to, let's imagine a case where you have multiple proxies, and so it is useful to do this quick aware proxying for flows that are going through the ingress proxy to this egress proxy. Next slide, please. So for reference, here are some of the capsules that we're using. So the client can register connection IDs that it has for packets that it's receiving kind of within the tunnel. It can register the target connection IDs of the end server that's getting to. The proxy can acknowledge those to say, yep, I am okay with using this for demultiplexing at my layer, and then either side can close them. So this allows you to have one kind of request stream, one connect UDP session, but then be able to add and remove CIDs as those change on the proxied connection. And it can support negotiating the virtual connection IDs to use, as well as communicating stateless reset tokens. Next slide, please. So of the recent changes, we have the virtual connection IDs. We also added text to describe the fact that it's probably good to do keep alives for an end-to-end connection that's being forwarded, because you may not have much traffic that's actually going on in the client to proxy connection that's not forwarding. So you may want to keep that other connection alive. There's some interesting implications from migration, handling for passive and active migration, and how those intersect with the virtual CIDs. We worked on text there, and we also tried to improve the text for ECN behavior. Specifically, this is not like the tunneling ECN mode. It's just forwarding, so you just forward the markings, and you're not worrying about IP and translating ECN markings into inner headers. And of course, a relay could add its own markings if it has a queue that's building up. So these are, I think, relatively straightforward, and we have, with a kind of a Cloudflare quiche base and our client implementation, we've kind of built out the current version of the draft and been able to test that. So it has two implementations at this point. So the big open issue that has been discussed, some on the list, that I think is kind of like the main thing that needs to be addressed in this, is about encrypting the payloads of the packets in forwarded mode. So as it stands today, when you are forwarding in this quick aware mode, you are, well, you're swapping IPs and you're swapping ports and you're swapping connection IDs, but it's not changing anything about the payload. And so if you are concerned about traffic analysis where someone is looking at traffic going into a proxy and also coming out of a proxy, it's certainly possible for them to recognize that, oh, well, you changed the connection IDs and you changed your IP and port, but the content of your packet is the same. And so you can say, this is the same packet here. It allows you to correlate that. That may or may not matter depending on what you're using this proxy for and what your threat model is. I think it's also important to note that if you have someone who is able to watch traffic on both sides of this, the timing information and the packet sizes are also usually going to give this away. But of course, you could have other mechanisms like padding or timing obfuscation that could help with this. So I think the main point is the fact that there is not a way to fix the re-encryption here and to make sure that these are not correlatable based on content is something that makes it impossible to remove the correlation. Doing that alone does not fix the correlation problem, but it is a necessary but not sufficient condition. All right, so next slide. So to re-encrypt or not to re-encrypt is the question, and how should we do it? Next slide. So I think there are two main questions here. First is like, how do we want to re-encrypt this without adding any size to the packets? The whole point of this is that we don't want to lose MTU. We don't want to have expensive processing, but we're also trying to remove the ability to trivially correlate. And then the second question, I think, is more of how do we fit this into an overall architecture? Is this re-encryption required? I think we have an option of saying, yes, for quick array proxying, if we're doing this forwarded mode, we must only ever do this re-encryption, or we say this is a negotiated thing that both the client and the proxy can say, I'm only willing to do forwarded mode if I have this re-encryption happening, or no, I don't care for this use case, let it go through. So I think those are the two questions I'd love to get feedback on today. Next slide. So there are two proposals that were on the list, and this is a paraphrase diagram, Martin, of what you did, and I changed the names of things. But like roughly, you have your original packet and you have your transformed packet. They end up being the same size. You have these different fields. You swap the CID for the virtual CID, and then you first encrypt the remainder, and then the first byte and the sample are changed. I think this is my impression is like this is just like a stab show. It's probably possible to do it. I did have some questions of this of like, is this weird if we're changing what the first byte is, and does that make it stick out amongst other quick traffics? But anyway, so we could essentially use AES-CTR as one mechanism and kind of split up the parts of the packet and use them as the nonces for the other encryption and come up with a scheme here. I think we would need a lot of good analysis and input from crypto folks on the right way to do this, but this is one approach. And next slide. Oh, the other approach Ben Schwartz mentioned was HCTR2. Here are some links to that information. I haven't gone into depth on these. The list discussion indicated that this probably requires 2 passes over all the bytes, so it's probably more expensive than some of the other schemes, but it also would be fixed size. Next slide. And so then the question on negotiation is, should forwarding encryption be negotiable? I think personally, I would lean towards saying it should be an option you can negotiate. It shouldn't be mandatory, but if we do negotiate it, we need to figure out how do we spell that in terms of what's happening in capsules. What is the encryption scheme? Does that need to be negotiated? Do we need to be able to communicate any key information or other algorithm information depending on what scheme we use? So next slide. I think it's the last slide. Yeah. So there's a question of, do we want to adopt kind of these quick aware optimizations for this group in general? I think if we do that, I would like to posit that this encryption work is very important to do, and we should only adopt this acknowledging that we should address this. Personally, as an author, and I'm working with David and Eric on this document, I don't think we have the crypto expertise right now amongst the authors to come up with the whole solution. So we would want like a design team, but I think that would be something great to have within the working group as a design team, and not just authors over here trying to like take stabs at it and hope we get it right and then see if the working group likes it. And then there's this question of, what approach should we take to encrypting forwarded packets? And I'd also like to hear from people if there are other functional features that we think proxies could have when they are aware that they're doing quick as the end-to-end protocol that we'd want to take advantage of. So we have a queue.
If I may, just to preemptively jump on that. No, go ahead, David. On the adoption question, we did go through, refining of the charter text, and it's like we have consensus amongst this group, but it's currently going through IESG approval right now. So we can talk about the adoption question predicated on the assumption that that charter goes through, because it does explicitly note this document as being potentially in scope.
Right.
Yeah.
Right. And so I think the question is more, assuming that the charter goes through, and if it has an item for we would like to do this, can we adopt this document as the starting point, assuming that we can, as a working group, rip it apart?
Exactly. Yeah, thank you.
Yeah, and to clarify that process, David Skenazy, MASQUE enthusiast. To clarify that process point, what you're imagining is we talk about the hypothetical concept of adoption here, and then once the charter is confirmed, we confirm it on the list, and that would be with the exact charter, because it'll definitely get some tweaks along the way.
Sure. Yes.
Cool. Thanks. So 2 points. The first one is on the first byte. I would say it's a very solvable issue. Like what we did for header protection is you do a mask. Oh, that's funny. On the number of bits you want to XOR, so you only do the ones that are I would do the same ones that are XORed by header protection, and that way we're done.
Great.
And that way the spin bit still works for people who care about that. Right. And then the second point is on the figuring the encryption out. Well, quickly, a third point. I don't think we necessarily need to negotiate it, because that opens a whole can of worms. And just like in Quick View 1, the initial encryption can't be negotiated. We can just toss AES-CTR in for now and call it a day.
We can negotiate whether or not we do it, though.
Yeah, whether or not we do it, absolutely.
But
not, or do you want AES or Cha-Cha or whatnot? And then finally, on the mechanics of how to do it, I totally agree with Tommy. No, it's fine. Trust the authors. We totally got this. We're not going to mess up the security at all. It's fine. So yes, please, let's create a design team with people who can prevent us from shooting our toes off.
Thank you. Mike
Bishop. This is low. So I am wildly in favor of adopting this document. I would say that as far as the encryption goes, one of the big benefits of this is the ability to shove that packet relay down to a lower level, potentially even to a NIC, and not have to spend your CPU time on it. And that makes me a little nervous about the more complex the re-encryption gets, the less likely you are to be able to do that. So either it has to be negotiable, or it has to be simple enough we can shove it in the NIC.
Very good point. I totally agree. And I think that's why the number of passes we need to take over every bit comes into play. We want this to be secure, but as minimal as possible.
But yes, let's adopt.
Okay, thank you. Martin. Yes.
Yeah, it's my turn now. So I think I'm in favor of adopting. I need to go back over the way that you're doing the virtual connection IDs, because I found the draft and the slides confusing in the short time that I looked at them. Yep. So I need to convince myself that that design is fine. But I think if I understand how it should work,
what
I have in my head is good. What you have in the draft doesn't match what's in my head, because it's a little bit unclear. But that's the only problem that I have with adoption. If I can convince myself of that, we're great. We definitely should do the encryption thing. The reason that I proposed the AES-CTR version of this one is that it is very close to what the quick packet protection does. Mm-hmm. And what I imagine we would be able to do then is, if the people building the quick packet protection in hardware are clever enough, they can reapply the same process here with maybe some small tweaks. And I think that's probably going to be better than doing a two-pass thing, even though, yeah, some researchers have come up with a great idea that manages length-preserving encryption, but I think probably in this case we can do something specialized. I don't have a particular opinion on the negotiation of this, but I suspect that I would like to say that my starting position is this should just be turned on, and it's relatively easy to go through the process of getting keys and whatnot. So we should see how far that gets us before we start to talk about turning it off.
Cool. Thank you. Other Martin.
Hi, with no hats, 2 points. First of all, regarding the encryption, I think you're underselling the benefits of it because, as you point out briefly in the security considerations, like one thing this does versus tunneled connections is that it removes the ability for the proxy to authenticate the packets. And you kind of nod towards that in your security considerations, but I'm not sure you fully thought through the implications of that. The abilities of some sort of attacker to like steal all the rate quota or whatever for a particular client. Just off the top of my head. I mean, there's probably some other things. So I would be a little scared about we need to really understand the implications of sending unencrypted, not having this additional layer of encryption before we authorize that, and to be negotiated. My other question is about performance. The case I'm concerned about is as follows. So let's say that the bottleneck is between the client and the proxy, and you have some connections that are tunneled and some connections that are forwarded. The congestion feedback will be end-to-end for the forwarded connections and will be proxy to client. So to try to skip some steps here. So the RTT on the forwarded connections will be much higher. And so I think there's a fairness issue with most congestion controls where the tunneled connections will have an advantage. So before we go too far down this path, I think it would be worthwhile to maybe do a few simulations or something to figure out, like, are we actually getting performance benefit out of this, or is the 10% overhead advantage being annihilated by getting half as much throughput because the RTT is much longer for the forwarded connections? Thanks.
Cool. Thank you. Yeah, I think it would definitely be worth noting those trade-offs and how tunneled versus forwarded interact. I think in the experience we were doing, essentially either 100% forwarding or 100% tunneling, and we have relatively tight control over the round trip between the forwarding and the target, but that may not always be the case. And so explaining kind of considerations that would be very important.
So in that experience, do you know where the bottleneck was?
We can go into it more offline. I think this is a good thing to discuss.
Yeah. All right. Yeah. Thanks.
All right. Thank you. I think it's good.
One more.
Oh, sorry, Maya.
Yeah, Maya Kulevin. First of all, I support adopting this document. About the encryption part, I wonder if we actually have a use case for it, because if nobody plans to implement that part, I'm not sure we want to put it in this draft. We can always have like another extension, adding it later, right?
I want to implement it.
Okay. That's just a question.
Yeah.
Okay, perfect.
We do.
And then about the congestion control, actually, that's a good point, because I think that is something we at least need to mention, because it's different from usual mask tunneling.
Good thing we have a transport AD and a former transport AD to help us fix congestion control. Thank you.
All right. Good. Yep. Thank you. Thank you, Tommy. All right. Yeah. Next up, we have proxy and listener UDP support in HTTP. Trying to pull up the slides now. We can drive for you if that's what you'd like.
Okay, that'd be perfect.
Okay, great. All right, take it away.
Good morning, everyone. I'm Abhi Singh, and I will be presenting the MASQUE Connect UDP listener today. Next slide, please. So Connect UDP, as it stands, it allows for only single 5 tuples or connected UDPs only. As you can see, you specify a path and where you specify a target and you connect. You can only access that target via the proxy. Next slide, please. So let's look at a use case for WebRTC. We have a Sten server. We have two users, Alice and Bob. Next slide, please. So Alice gets WebRTC connectivity through the Sten server, and Alice and Bob establish a peer-to-peer connection for a voice call. Next slide, please. And now here's a case where Alice is behind a proxy. And so the Sten server would directly be connecting with the proxy, and so will Bob. Next slide, please. Yep. Next slide, please. Oh.
David, are you having issues connecting? Oh, never mind.
Okay.
I was going to ask if you could share to drive, but we're good. We're good. We're good.
So here, the voice call would be established through the proxy between Alice and Bob. Next slide, please. So in Connect UDP, for this to happen, there to be a connection between Alice and the Sten server and then Alice and Bob, Bob would need to access the same IP address, which would be of the proxy. Could we do this with multiple connections? Next slide, please. Unfortunately, in HTTP, HTTP semantics, due to HTTP semantics, we can't really guarantee that it will be the same IP address servicing both Bob and Alice, and therefore ICE will break. And this schematic will not work. Next slide, please.
Sorry, I added myself, but I'll do that later. Eric Rescorla. Go back, please. So I guess I'm a little confused because there's like connect. So you have one quick connection between Alice and the proxy, right? And then you do two connect UDPs, right?
Yes, in this case, we're showing two connect UDPs, but that would not be that may not be possible because the proxy may not run on the same IP address for both connections.
But no, but you only do one quick connection. You start with one quick connection, right?
And
this is exactly the problem that Turn has. So I'm trying to understand why this is different.
Exactly.
Yeah, and so David Skenazy, jumping in as co-author. So the issue here is in HTTP semantics, you could have a single quick connection to your first HTTP intermediary, but then they could send the connect UDP to different servers on the back end, which would then have different IP addresses. So that's why we want to, instead of having separate connect UDP requests, if you put them on one, you're guaranteed to be coming out on the same box.
Yes. Don't do that then. No, I mean like an enormous amount. Like when Term was first designed, there was like a huge amount of angst about exactly this topic, and a whole bunch of compromises in Term specifically designed to avoid allowing people to exfil effectively servers outside the firewall. And so unless you're planning to reconstruct all those Term permissions constructions, like this easiest solution to the problem is not to do this, is to fix your HTTP semantics so they do in fact pin to the same IP address.
Well, it's really not in our purview to change HTTP semantics. And I don't know if Emnod is in the room. He'd probably have thoughts. I get what you're saying. We have more slides about those bits later.
Okay.
right, so next slide, please. Sorry, previous slide. Yeah, so now connect UDP with listener support with infinitely many tuples. So using one connection, you could specify multiple targets. Next slide, please. And so the way we would do this is we would have a path, and as you can see, we're not defining a target in the path. In fact, instead, we're doing it in the quick frame itself. The IP address and the UDP port are provided. So that's, next slide, please. So what these fields mean, so from the client to proxy, the client uses it to specify the target where it wants to send these UDP packets. And from the return from proxy to client, that this is the source where the proxy is receiving the packets, which source it's receiving the packets from. Next slide, please. So the last time I asked for some input from folks regarding WebRTC, like since we needed some WebRTC expertise, since there are some similarities with that and Connect UDP listener. And there's these are the feature requests that we opened on our GitHub. And so thank you everyone for participating in the mailing list. Next slide, please. Yeah, so the first one is thanks to Peter Thatcher for this. And so allowing the proxy to send the public IP and port to client. So the potential ability for the client to retrieve the proxy's outbound IP and port addresses. And this would be useful for ICE and prevent turn-like use in certain cases. Go ahead, Tommy.
Tommy Polyapple. So for this, do you have a proposal or thought of how you wanted to send the information back yet or not?
I don't think we had anything at the moment.
Okay. Just one thought that comes to mind is like, so we have an interesting line here between things that are specific to UDP proxying and like MASQUE and things that are generic HTTP. And there are certain things like the proxy status header that we're doing stuff with that's from HTTP. I wonder if this is like a generic bit in which proxy status tells you next hop. Could we just have it also include information about, I don't know what you call it, like the thing I use to talk to the next hop. And then we could do that for connect proxies too, or anything. And just like, here's the address I assigned you on the outside. And that would be very useful here, but it would also be useful. For, what? Yeah, exactly. But I mean, right. So I'm just saying like, this may be something that we need to solve by and potentially split out into a different document. Okay. That does not belong necessarily in MASQUE because it could apply to more things than UDP.
Sorry, but once you had that, you don't need this. So like the way turn works is that the turn server tells you what your exterior IP address is. You don't need to contact this done server. And so the entire problem statement you have from like 2 slides ago is irrelevant because all you have to do is ask what my exterior IP address is, and then you can just open and you can just bind a connection to the target response.
So yeah, I think to solve this, what we really need is just the ability to have the same local IP and the same local port through the proxy. And there are different ways to spell that, right?
What do you mean the same local IP and the same local port?
No?
That's not how this works.
Okay, like, tell me what we need.
So like the way, like,
oh, you just need to communicate.
What I'm saying is what turn does is turn emulates a NAT,
right?
And so but turn does not need an exterior stun server because the way turn works is when you create a binding through the turn endpoint, the turn server tells you what IP address is assigned you, and then you simply shove it in your ICE candidates. And so the problem statement of having two different UDP connections that have to have the same exterior IP address is the same server reflexive IP address is irrelevant because you don't need to talk to the stun server ever. And so the way turn works is you say, please assign me an exterior IP address. and then you send outgoing packets through that It emulates an address independent NAT, binding NAT.
But we do need the ability to tell, because we need to get an exterior, like a proxied IP address and port. We need to learn what that is, and we need to be able to accept incoming traffic on that.
No, that's not how. No, you don't. That's exactly. It's like, again, we're inventing ICE here, which is very frustrating. So the way ICE works is that so in any address independent. So if you have address independent binding but address dependent filtering NAT, right? Then what you do is you register a binding through the turn server, and it tells you this is the binding I will use for every exterior thing I want to send to and receive to, right? And then what you do is you transit outward the connections, right? Okay, like I mean, it's just like maybe I'll have to write this down. So this is like
so I mean, and here's a question. So with the current Connect UDP, there is no way to either learn what outbound address and port you have, or to request it for new 5 tuples. Right. Without that, it is we cannot solve this currently. So with right. So you're saying like we can solve this as long as we can know what address and port we were assigned and be able to use that same address and port for future outbound connections. Right. And I think this is potentially another way to spell that. Like you could do that, but that is a way to solve this. That is potentially simpler.
But the important thing that Turn does is that it doesn't allow arbitrary remote connections through the same address. You have to send a packet out to open the pinhole. And that is precisely the security mechanism that was invented for WebRTC to avoid having good.
Yeah. David Skenazy, just jumping in really quickly as co-author. So the issue here is the problem statement is we want to be able to do WebRTC over Connect UDP. So the way Connect UDP is spelled right now, when you get a datagram coming down from the proxy to the client, it only ever comes from that original IP import that you poked at.
Sure. It's called address.
Yeah. And so you need a way, if you're sending another packet to the client, to say, this one's coming from somewhere else. Right?
You mean a way to carry the remote address?
Yes. Yeah. That's pretty much all this draft does.
Yes.
I know, but
because the remote thing might have address dependent address.
Right? Yeah.
Just to clarify here, my impression is like there is a difference in the approach here, because I believe what the current draft is proposing is you ask the proxy to say, give me an IP and port that I own that you will allow me to receive from any arbitrary place on, which if you do have that, I think you could implement this, but you were saying that for ICE in turn, what we need is just the ability to have specific 5 tuples that share a local port on that. And that's all you need for the WebRTC.
So because of time, I'll move on to the next couple of slides and maybe we could discuss after. Okay. So next slide, please. So here's another one from Peter Thatcher. It was about, do we want all IPs to be able to send data to the client via the proxy, or having an allow list of IPs that are allowed to return to the client via the proxy? And this mechanism is also prevalent in Turn to prevent Turn being used as a server. And next slide, please. I'll go through the last issue. And so this one's from Ben Schwartz about compressing away the IP and the port. Currently in each datagram, we have proposed the IP and the port to be present there. And this adds a lot of overhead for compressed audio formats, like Ben Schwartz said. And David Skenazy recommended perhaps registering a context ID for the IP and the port. And so for each datagram, we don't have to carry this overhead. And that would be it. We have a couple of seconds for a question. Ben Schwartz.
Hi. So I think this is important stuff. I think it should be adopted by the working group. I think the draft as is a good enough starting point. And on the specific topic of allowing inbound traffic, I think that Turn, in my view, actually made a mistake here and ended up mixing up essentially mechanism and policy. Really, I think what we should build here is a very generic mechanism that just lets you open a UDP port and accept whatever comes in. And then as a matter of policy, servers are welcome to essentially place a stateful firewall on top of that so that inbound packets are dropped unless there's been an outbound packet to it. But that, in my view, is not part of the protocol. And that's sort of it's a separate component. It's just something that you can place in front of your server if you want.
Okay.
The other thing I'll mention here is all of the stuff we just talked about with quick optimizations to reduce overhead could equally well apply to SRTP. And so, I think there's an interesting question about what the right conceptual framework is, whether we're being a little bit too narrowly focused on quick there.
Right. Okay, I think that makes sense. What do we have next on?
Mike Bishop.
Yeah.
So I think that kind of ties into what I was going to ask, which is Ecker alluded to the possibility that you might run a web server over this. And I don't think it's entirely clear. I mean, obviously you want to support the WebRTC case. Are we trying to rule that out, or is that actually a use case that you might consider? Because those might lead to two different designs.
Like pulling WebRTC out?
No, like, would it be a use case you would consider in scope for a client behind a proxy to stand up a web server on a port allocated to it by the proxy?
Right.
And I see a thumbs up from David. Are you saying that is something you want to support?
Yeah.
Yes. Okay.
So I think I'd like to recap how we got to the situation we have with Turn. The way we got the situation with Turn is that a large number of enterprises run stateful inspection firewalls. The stateful inspection firewalls are designed by and large to enforce an outgoing only semantic. That's the semantic for TCP and the semantic we're attempting to enforce with UDP. And Turn was designed the way it was on the thesis that if it was built so it had a generic incoming packet capability, like Mike just proposed, right, that the result would be that it would be blocked by firewalls, because firewalls would say, this breaks the semantics we have. And so so we can't allow it at all, right? And so you just went to war with the people who run the firewall. And so the reason why Ben's design does not work was because, for that purpose, is because the idea was you're supposed to determine you were doing Turn and say, this is obviously Turn, so it's cool through the firewall, because it's not just opening a hole in the firewall for an internal server, right? Mm-hmm. Now, this is 2023, it is not 2013, which is about when this other stuff was designed. So things may have changed, but like these were design decisions that were made very consciously when Turn was designed precisely for this purpose. And so I think like, it may be, and so I think it is a much bigger decision than the decision for this working group, whether to essentially just like completely break the effective compact that was made with the people on the firewalls that we were not going to do exactly this thing. And so like that may be the thing to do, and maybe firewalls are over. So I'm not necessarily like opposed to that, right. But that is how we got to the state we're in now.
Okay.
And so I think before like this working group adopt this, it's really worthwhile going back and looking at and the fact that I just see you triumphantly reinventing every single piece of Turn, start like going to channels and whatever, is like just like really we should go back and look what the design of Turn is and be like, are those assumptions now wrong? In which case we do something different, or is it just that Turn is like no longer the protocol semantic in vogue. It is, and we think we should use this thing instead. And I guess let me just say one more thing. Like there is like turn over DTLS, and so it's not actually like the case that you cannot do like turn, with you cannot do turn with security and not have line blocking. So again, like I'm not like opposed to doing some kind of turn like thing, but I'm just saying it's one thing to say we want to do that. We're trying to keep the same set of agreements we had before, and all we're doing is modernizing the protocol. It's quite in order to be we're totally opening the aperture and we're just totally different. And so I think that's like the question to ask. And if once you do that, then it requires different things, different answers, right?
Okay, I think.
Right, yeah, that's it. Thank you. I guess we'll, in the interest of time, move on to the next presentation, which is. What's the name of it? Oh, thank you. Datagram retransmission. Yes, we'll pull up the slides. One moment.
Okay, hello everyone. I'm Yamif at Alibaba. Today my talk is about the retransmission extension of HTTP3 datagrams. Next slide, please. So our use case is to accelerating the quick in our mobile application with UDP tunneling. We will have a tunnel proxy on the edge pop, and the client will build a tunnel connection to the tunnel proxy. And then the client will send the end-to-end quick packets through the tunnel to the tunnel proxy, and the tunnel proxy will pass these packets to the IDC, to the data center. Next slide, please. There are two ways of tunneling quick connections in MASQUE. We all know that the first way is using the reliable way. We can send the end-to-end quick packets through the datagram capsule in QuickStream. The other way is using the unreliable way. We can send the end-to-end quick packets through the quick datagram frame. And there are some pros and cons. In the reliable way, we can do the local loss recovery between the client and the proxy. But it will cause some head-of-line blocking, especially when we send parallel end-to-end quick streams, which are serialized into one single quick stream. And the unreliable way will not have any head-of-line blocking issues, but also we don't have a local loss recovery as well. So we can see that the retransmission of datagrams is appealing for the performance enhancement. It's optional, but it will help when packets are lost on the last mile. Next slide, please. So the next question will be which layer to retransmit the datagrams. We still have two options. The option one is to add a transport parameter at the quick transport layer to negotiate whether quick should retransmit the datagram frames. It's connection level, but it's not very inflexible. The other option is that we can configure the client and the proxy to retransmit HTTP3 datagrams, which when they are declared lost by the transport layer. But how? The next slide, please. So our basic design principles at first we should make sure that each tunnel should have its own configuration, its very flexibility. And we also should be able to limit the retransmission overhead, because we will not want much traffic calls caused by retransmission. So next slide, please. So our design in our draft is the extension for HTTP3 datagram retransmission. At first, we add a new Boolean value item structure field, which is called the DG retrans, to negotiate the use of this extension. The client could send this field through the connect UDP headers to the proxy, and the proxy could decide whether it will allow this extension. And if the proxy responds to the client, then the client could use the retransmission limit to control how many times an HTTP3 datagram can be retransmitted. And I think that for client to server packets, the client could decide the limit. And for the packets which are sent from the server to client, the client uses capsule type set H3 datagram retransmission limit to inform the proxy its limit and its upload value. Okay, next slide, please. So the next question would be why we need the retransmission to be limit and how to set the value. Because we want to have some control over the retransmission overhead, but there may be better ways to do this. And also, as Ben has suggested in the mail list, the client could also report some transport performance metrics to the proxy, and we can configure it dynamically in the proxy with these metrics. So how to set the value? We give a very simple way. One possible way in our use case, we use RTT2 divide RTT1, which the RTT2 means the round trip time between the UDP proxy and the quick server, and RTT1 means the round trip time between the quick client and the UDP proxy. So the main idea is to stop retransmissions once the end-to-end connection would have done it. That it's a very simple way, and you can use it dynamically in a more powerful way. So next slide, please. Okay, then we have done some experimental in our scenario. We send 20 parallel 5 KB requests every 500 milliseconds, and we use congestion control BBR in the net link from client to proxy and proxy to server, and we set some random losses which are added on the client to the proxy, which simulate the packet loss on the last mile. And we have drawn two conclusions from the experimental results. When the loss rate becomes 5%, we can see that in the metrics, the first conclusion is that compared with the reliable mode, the unreliable mode achieves better performance due to it not suffering the head-of-line blocking issues. And the second conclusion is that compared with the vanilla unavailable mode, the unavailable one, which set the retransmission limit to 1, achieves better performance due to the local loss recovery. And it's a very simple experimental. We can do a better way. We can use dynamic values to use it in a more powerful way to get better experience. Next slide, please. Okay.
Can you just go back? Okay, so purple's reliable, orange is the current thing, and gray is the thing you're proposing, right?
Yeah.
Lower is better or lower is worse?
Lower is better.
Great, thank you.
The next slides will be some open discussion. So the first question is that, is there a better way to replace retrans limit, or we have better ways to set the retransmission limit? Our opinion is that we can use dynamic ways, and we can use some metrics from the network measurements. For example, the round trip time, the estimated bandwidth of tunnels, and the end-to-end connections. we can take loss rate into consideration. And maybe we can do some adaptation logic as for open discussion. The next slide, please. Okay, the most discussed problem on the mail list is that the retransmission impact on the end-to-end congestion control. I think that for non-loss-based congestion control, for example, BBR, it seems fine. But for loss-based congestion control, the retransmission might hide losses by local retransmissions, may delay the loss-based end-to-end congestion controllers to react to congestion. It may lead to bloated sending buffers in the tunnel connection. But some AMQ mechanism, for example, RED, will be introduced in the tunnel connection to actively drop queued packets to elevate this problem, and it's an open discussion. Next slide, please. The last problem is for cascaded proxies. In our case, we just have the first hop link. So the packet loss was most happened in the last mile from client to proxy 1. So we mostly use this extension in this side. But if we have several hops, maybe we should forward the capsule to the next hop if the packet loss happened in proxy 1 to proxy 2. So it's an open discussion, and we could do the extension in the future. I see several people online. Martin.
Yes. So first of all, dividing the RTTs by each other doesn't work because you have act delays. Second, if your assumption is that the bandwidth bottleneck is between the client and the proxy, and loss on that connection is the only signal you have for the server to stop sending if you're using a loss-based congestion controller. So now you suggest doing some AQM, which means dropping packets. But now this is the problem that you wanted to solve in the first place, that packets are dropped because of because the bandwidth is used up. Third thing, simulating random packet loss usually doesn't make a lot of sense because packet loss is not random. So I'm a little bit, I'd be a little bit careful with these results.
Hi, Alex Chnahovsky. I'm looking at the presentation and the draft here. I'm actually finding myself wondering if we even need an extension to accomplish the results that you have here. Looking at the primary option that you're presenting with the retransmit limit is specifically in the example that you've presented here, the client here is the mobile phone, the thing that actually has the least amount of information about the cellular situation. The thing that actually has the vast majority of the information about the airtime availability and the loss is not the client, it's the proxy itself, assuming that it can be embedded with the base station radios. So from my perspective, the retransmit limit is actually something that the proxy itself is in a much better position to decide, especially since here, either for Connect UDP or Connect IP, you don't have any visibility on the inner protocol anyway. Specifically, since you did your experiments trying to tunnel quick, you don't have headers available to you because the data is encrypted. So I don't really see any particular value in the setting that you're proposing. I think you can get the exact same effect purely just implementing this capability on your proxy.
So it's just a starting point. I think more mechanisms could be done in the proxy.
Hi, David Skenazy, still a mask enthusiast. So first off, thank you for presenting this. So I want to make 2 points. The first one is regarding your experimental data. I'm assuming you used uniform, independent, randomized loss in your simulation. Is that correct?
Yes.
So in my experience doing some research in this space, that's generally not correlatable with reality, because in all networks, as far as I can tell, loss is not independent and uniform. It is highly correlated because, congestion and airtime and all such things. So I would recommend running the experiment in a real world scenario over an LTE network. And I would love to see those results before to help motivate this, because I'm not clear that we would see such a win. The second point is I want to highlight for everyone in the group that there has been an IPR disclosure on this document. And it's not from you, it's from the folks at Ericsson, who have a patent titled Selective Quick Datagram Payload Retransmission in a Network. And so first, that would be a problem for adoption. And second, I just want to say to our Ericsson friends, that's not cool. Like, this stifles innovation in this working group. So I'm really not enthusiastic about that.
Hi, Yunfima from Alibaba. First, I want to answer David's question. Yes, we actually did some experiment in the wild, but not with this work. And we do see that, okay, the loss is correlated, especially in the LTE, because you have the retransmission on the MAC layer. And also in the mobile network, you have deep buffer. So when the loss happens, is mostly bursty loss. Yeah, so but my point is this work is just like a starting point. I think we can also think about try to expand the semantics, right, to incorporate other capability, not just limited to the retransmission. And also for the second point, I think we also want to ask the opinions from the working group, because I think one problem we have is how do you differentiate between the congested loss and the random loss? And how do you design a congestion controller that can reliably tell us that? And if anybody in the working group has a good idea, please let us know. And we really appreciate it.
Yes, thank you.
Hi, EMA. Here's Chuanma from Tsinghua University. I have to say that I really like this proposal, because I think the use case is really clear that we may have some circumstances where we have to retransmit the mask datagrams again, so that we can enable some reliable transmission or reliable transmission protocols like QUIC. And we may encounter some random loss during the client communicating with the AP. So I think the general idea of this proposal is great. But in my opinion, this is kind of overcomplicated by running QUIC to leverage some kind of encryption and reliability over HTTP datagram over mask system. So I think there may be some better solutions to seize some complexity, like you can match the QUIC stream to the datagram, using the mask datagram to send UDP datagram and match the different, you say, datagrams to different QUIC streams to avoid retransmission or to let the QUIC to help you. So I think that it's a good proposal, but maybe there are some better solutions.
Thank you for your suggestion.
Ted Hardy, RLP enthusiast. So I would like to thank you for bringing the work to the IETF. Thank you very much. And especially I would like to appreciate that you brought experimental data to go with it. That's always very helpful. I agree, however, with David that the experimental data may in fact not match the needs here, in part because of the correlation issues he raised, and in part because many of the networks you identify as the potential sources of these loss, in fact, have mechanisms to deal with that loss that go back several generations in radio technology. RLP, for example, was something invented for CDMA because they identified exactly this problem for TCP. Whenever TCP had a radio loss, it thought it was a congestive loss and shut down. And especially in pre-Reno congestion controllers, it kind of was like a very bad scene. And they put in RLP to say, okay, we're going to make sure that no matter what else happens, this last hop of the link will look utterly reliable, even though the radio field was as full of crazy as it is today. And the result of that was an enormous amount of jitter. Because even before we called it buffer bloat, it had to have a big buffer in there to make sure it was there with the cross correlation of losses that David referred to. You ended up with bloat and jitter, and you were trading one problem for another. And especially because the use case that people had for CDMA networks was this thing called voice, a lot of jitter was a problem. So I think if you experiment with this on a modern network, you will find that the lower layer mechanisms of hybrid ARQ and FEC are actually handling this for you much more often than you think. And although Miri posted in chat the remarkable idea that you might turn off hybrid ARQ in order to use this one instead, I'm just astonished by this notion, and I shall have to go and lie down as I think about it. I think functionally at this point, a little bit more experimentation may identify for you that this is either not the theoretical problem that you have identified, or that there are much narrower cases here. And those narrower cases, I'm almost certain, will result in a different design. To the point of an IPR that David made, there was patent stuff on RLP that expired at least 10 years ago. So if you wish to go and talk to the patent office about somebody reinventing the wheel, that is, of course, your privilege. Thanks.
Thank you. We will do more experiments later.
Ian Sweat, Google. I mean, I think there's certainly possibly work in this space, but yeah, I think this needs a lot more experimentation. The number of retransmissions in particular seems like a potentially problematic choice. I probably would choose a time target or something like that. Like an obvious quirk of the number of retransmission thing is if the downlink from the proxy to the client gets congested, then you start, building up potentially like infinite or close to infinite buffers in the proxy and things like that. And control loops get really, really wonky if you start introducing a huge amount of jitter. I'm also curious, like, there's a prioritization question here of like, do I retransmit things that were lost, or do I like proxy through like new packets first? If I'm congestion limited on that last hop. So yeah, real world data would be a lot more helpful, I think, on a number of levels, also for comments that Ted made about retransmitting on link layer and things like that.
Okay. All right. Thank you very much.
I was just going to add one more thing about one thing you have to measure. So you measure primarily data. You measure primarily data, how much overhead of spurious retransmission you had. But as Ted was saying, one of the things with voice and video is that if you retransmit it eventually, but it's too late, it doesn't really help you very much. And so I think it'd be useful to also measure some kind of jitter measurement. So you're able to measure how likely it was. Like a voice packet, basically, if it's not delivered within 50 milliseconds or 100 milliseconds, is not useful. And so if you're able to simulate like sort of the kind of loads where you have voice where it's like continuous packets of really small, and then in the same losses, and look to see what the like sort of mean delay time for the retransmission was, or whatever, like something for jitter, then it would give us a sense of whether this actually works in those scenarios or whether it's just kind of a problem. Obviously, like IP is different, but like voice is kind of different.
Okay, thank you for your suggestion.
Awesome. Thank you very much. Next up, we have numbered HTTP datagrams. And while we're getting set up for that, we'd like to remind everyone that we operate under a code of conduct in this working group, and please keep that in mind when you make your comments.
All right, I'm going to talk about numbered HTTP datagrams. Next slide, please. So I briefly talked about this last time. It's a pretty small extension. We're adding numbers to HTTP datagrams. You can indicate support by setting a header. You can register the use of these numbered datagrams by sending a capsule, and you define a context ID for that. You can define the size of the packet number space you want to use, and then you can use these sequence number datagrams. It's a very simple proposal. I'm not talking too much about that. I'm going to talk a little bit more about motivation for this, and then we can see if this is something that people are interested in working on. So next slide, please. So why do we want to do this? Next slide, please. So we have this thing in 3GPP called ATSSS. The latest version of this document called TS23501, version 18.1.0, has added MP quick steering functionality to ATSSS. ATSSS is used to handle traffic over 3GPP and non-3GPP accesses in parallel. You can do this in various modes. You can do modes that where you switch traffic based on various conditions. You can send traffic in parallel using something called like a load balancing scheme. You can duplicate traffic using a redundant traffic sending, etc. And there are different protocol stacks that can be used for this. And recently, MP-Quick was added as one potential use for this. So next slide, please. So if we go really, really deep into one of these documents, so we have clause number 5.32.6.2.2.1. It's going to take like 20 minutes to actually get to this clause because this is in a huge Word document that you can go take a couple of cups of coffee while you let this spin up. Doesn't matter how powerful your machine is, but anyway. We also described two datagram modes, and we have datagram mode 2, which is the default mode, which is also fantastic, I think. This is the standard datagrams we use today. It's unreliable. You don't get any sort of packet reordering done or support from that in the HTTP layer. But then there's also a mention of a datagram mode 1. This is defined as an extension to how how datagrams are sent in the current RC 9298. Here the idea is to add sequence numbers to the datagrams and allow an endpoint to perform some form of reordering or deduplication of packets, and we're going to talk about that. And this is an optional mode. So when you implement IETF using MP-Quick, you need to support datagram mode 2. You might support this one. So if we go to the next slide. So one use case then is reordering. So IETF defines a bunch of steering modes. Some of these are like what we call active standby or switching based on like delay parameters and such. But there's one called load balancing, and this one you really aggregate traffic over two paths simultaneously. And there might be then for these cases there might be useful for an endpoint to sort of reorder packets that are, or datagrams that are arriving out of sequence before you pass it on to an application. You could do this by sending datagrams reliably over capsules, over streams, but then as we saw in the previous presentation, you kind of overdo it in a way. You potentially introduce head of line blocking. You have to perform the retransmissions and everything to deliver stuff reliably. So an alternative approach to this is to use the sequence number extensions, and you can do some limited type of reordering. You can delay incoming packets on a slower path by some short amount of time to try to deliver data in sequence, but you give up after some time if that's not possible. Like for instance, if there was loss or something, you don't try to fix that. So that's one of the cases here. And if you go to the next slide. We have the other cases we call deduplication. So in IETF, there is a redundant steering mode that basically allows you to duplicate traffic over the two paths simultaneously. So if you have some application that has some very, very strict needs on delivery, like you can duplicate the traffic, and you need some way of deduplicating it. I know you can do that on multiple layers. So if the end-to-end traffic is running some security protocol, that would probably do it for you. But it kind of makes sense to do this in the layer where we do duplication. So if you have sequence numbers on your datagrams, it's a very easy way to detect which packets are already duplicates. So that's the other use case. And if we go to the next slide, oh, we have a bunch of people in the queue. Do people want to come up and talk now, or at the end I have like 2 slides? Okay, so some use cases for when this is used. I think most of these uses where we kind of duplicate and aggregate traffic is not intended for kind of standard mobile broadband users. It's more like you have a campus with existing Wi-Fi coverage augmented with 5G radio. You might want to have a single management plane for your subscribers. You have devices which are mobile where you move in and out of coverage of Wi-Fi or 5G. Some of these applications require kind of consistent and good quality, so you want to do either aggregation or redundant traffic steering for these things. We have use cases around emergency response teams where we kind of want to duplicate traffic over multiple accesses to ensure that we kind of have the best quality of their applications, pretty much. So, yeah, I think we can stop here. I have the next slide is some other discussions on like this is a discussion on extensibility, but I guess most of the comments so far is more on what we've been discussing. So before we go to this, we can probably take the questions.
Hi, Alex Shanahovsky. From a wire format perspective, I think this extension looks fine, although I kind of wonder, based on the applications that you're describing, if it goes far enough. Given that one of your stated goals is to do things like avoid head of line blocking, by having a single sequence number for these datagrams, it means that presumably the types of protocols that you're most interested in tunneling over this are going to be things like QUIC, which fundamentally have multiple streams. So I'm sort of confused as to how you're getting the types of benefits that you're purporting to have if you're not necessarily aware of the types of protocols that you're going to be putting over this. Because, for example, you know, QUIC can have lots of different frames in the same packet, which can contain multiple streams. And now we're talking about like what happens if the QUIC level retransmissions are going to be affected based on how you do reordering there. So like, it feels to me like the wire format questions here are almost not the interesting parts. It's actually more about the like how you layer things and make this work well, which makes me feel like there's a huge problem space with this extension that possibly needs a lot of thinking before we even get to the point of deciding the wire format.
Yeah, I think that's a very good comment. For sure, you can really go deep down in this, and I think definitely if you have QUIC with multiple streams, that opens up a whole new problem space. I think, but still comparing this to running it purely reliable, then at least we remove some parts of those issues, because at least we wouldn't like block everything to do retransmissions and such. But I agree. This is potentially a deep problem. Yeah.
QUIC was designed with the insight that for an endpoint, it's always better to have a packet as early as possible. There's no point in receiving a packet later if I can have it earlier, because there could be something in the packet that I want to process. So I don't really understand why I would have something in the middle of the network that artificially delays my packet. Now you can say, oh, it's multiple paths, and then packets arrive out of order, and this confuses quick loss recovery, quick loss detection, and might have like some congestion controller benefits. But then I'd argue that this is something that should be solved on the QUIC layer instead of by a proxy that reorders packets.
Sure, but that's assuming that it's always QUIC that we have in this end-to-end tunnel, which so it could also be for non-QUIC applications. You can have, for instance, you can have some use case can here be some kind of remote control device that's going through areas. You might not be using QUIC for that. You might be using QUIC, which is great. You might be using other protocols to stream video or whatever from these things. So yeah, I understand. For QUIC and for modern transport stacks, I think they can handle reordering very well. This is an optional mode as well. So for you, like if you have an application that do not need this, then you should not negotiate the use of this extension. I think that's an important point too. And then we also have the case where we duplicate the traffic over both accesses. We're actually sending it redundantly, and having a sequence number is a kind of simple way to just deduplicate. I'm sure you can do that in other ways as well, but this would be one way. Yeah.
Hi. Ben Schwartz. In general, I think that we should be pretty open to extensions, but I just am very confused about how this is supposed to work. Are you saying that, like in the duplication case, are you saying that the QUIC packets containing HTTP3 data would be duplicated between the HTTP client and the MASQUE proxy?
Not the QUIC packet. The payload of these datagrams would be duplicated and sent over. So and those could be in the end-to-end. Those could be payload of whatever protocol you're running end-to-end, right? So.
Okay, so then anyway, I'm having a lot of difficulty figuring out where how this actually fits into the MASQUE architecture. which necessarily has a single HTTP client and a single HTTP server? Like, am I?
Yeah, you're running multipath quick under it. That's the assumption. I guess I should have been more clear. Yeah.
So even if you're running multipath quick under it, quick, for example, is going to handle all of the duplication by itself, right? Quick has.
No, because it's not sure that you have end-to-end quick, right, between the target and the client. So.
No, I mean between the client and the proxy, we're speaking quick.
Yeah.
So if a packet is duplicated, maybe I'm wrong about this. I'll ask the group. If a quick datagram is duplicated by the network, is it going to be received twice at the HTTP layer?
No. I don't think so.
Yeah. David Skenazy. Before I make a comment on this, I wanted to address something about my IPR comment earlier. The chair has rightfully pointed out that was over the line, so I want to offer an apology to our ex and friends. Sorry, I got carried away.
No worries.
Regarding this draft, I agree with the discussion so far. I think when you have Quick or TCP running over this, it would make things worse. We saw that at a previous employer when the cellular baseband was reordering packets. That made sense in old stacks for TCP, but in modern stacks, the sooner you get the packet, the happier you are. Yeah. I think if you add some text to very clearly scope this to cases when you don't have those, then it makes sense. My personal take as a Quick enthusiast is you should just put Quick everywhere, and that way you don't need to solve it at this layer. But I can see that there are times where you can't. So if you scope this tightly, then it makes sense.
Sure. Okay. Thank you. That's a good suggestion. Yeah.
Tommy Polly Apple. So thank you for this. I think this is a good discussion. It seems like there are two halves, right? There's like fixed reordering, and then there's fixed deduplication.
Yep.
I think on the reordering, making it very clear this is for non-quick, et cetera, protocols. Like I know, having written like an IETF stack, which has like really basic kind of dumb reordering, fixing, and the handshakes, like this may smooth things out on particular implementations. I think it's probably the less interesting part of the document. Like it's probably necessary for practicality, and we should have it in there, but maybe it shouldn't be kind of like the flagship reason why this is a cool extension. Yeah. I do think the deduping is quite interesting. And so just to try to explain it and how I am thinking of it to Ben's comments. So if we do have MP Quick, which is when you're doing streams, it's very similar to MPTCP, where at the transport layer, it is handling the uniqueness of a stream frame. And so when I send a particular chunk of data for stream 0 on one path and another path, that can be deduplicated by the Quick layer, and that's great. Datagrams cannot do that because datagrams do not have any semantic other than the stream they're associated with. There's no way to know what byte or order this is. And so I think this is actually a very cool thing that once we have MP Quick and we want to be able to do like these cases where we have more aggressive duplication of packets, which is definitely needed for some like super interactive cases where it really, really matters, that you will need the deduplication because that is something that Quick datagrams especially punted up to the upper layers. And so I think it's kind of like something you need for MP Quick with datagrams for certain modes of MP Quick that are not just about handover. So I would love to see this be kind of like the flagship use case of the document, because I think it's a really good future direction.
Yeah, thanks a lot. I agree.
Ian Sweat. Yeah, I think there are a few use cases of this. In terms of reordering even for Quick, actually there could be use cases where it's useful if you could actually use the IDE to reorder where the downstream link is congested. And so you have some number of packets that are in a reorder buffer just naturally that you're queuing up. I mean, various portions of the software stack do this for TCP all the time. So I don't think it's totally useless, although it does seem like the number of use cases are complicated and difficult to reason about. But I think, yeah, probably the deduplication one is the most clear win, with the other use cases being more experimental in my mind. But certainly an interesting idea.
Thanks.
Just one, Yunfei from Alibaba, just one quick comment. So actually, at Alibaba, we also use this sequence number for deduplication. And I think this is really important work. But right now, we done this in our, it's not the exact same format. But I think later we can try to share some experience data.
That would be excellent. I would love to talk to you more about that. Yeah.
So I really think this deduplication is for us because we have implemented, we have tested. It's really, really important. So I really think that this working group should adopt this work.
Okay, great. Thanks a lot. Yeah, I have one more slide, but I think we can skip that. It's a discussion on extensibility because the idea here is that what happens if you have various payload formats, like we're assuming currently that you're running this. We only have one payload format so far defined in this group, or like two, one for IP and one for UDP. What happens if you have multiple formats and you want to have sequence numbers on multiple types of datagrams? We need solutions for that. There's one simple solution here that might not be the best solution, and this is probably something, if we continue work on this, this is something that should be discussed. But in the interest of time, we can skip that now.
All right, thank you, Marcus. Last up, we have Lucas.
Hello, everyone. It's me again. I'm more awake than I was in London for various reasons, which is good. This is I can't have lost count. I've presented this idea a few times to the MASQUE working group. I think we should use this discussion to figure out if this is something we really want to do or just not bother. So I think possibly where I've not explained the problem well in the past to focus on the technology of the protocol. I'm not going to do that today. I just want to explain what I think one of the problems is using Connect UDP as an example with MASQUE, because that's what we are here to discuss. I think the problem would extend to other things like web transport or media over QUIC, but I'm not going to explain that. Use your imaginations. So next slide, please. Just quick reminder, there's HTTP extensible priorities. It's an existing draft RFC 9218. Effectively, it's got all the technical details I just said I wouldn't go into, but priorities are there to signal between a client and the server something, an intent or an usage or whatever. You don't need to second guess these things, but the important thing to know is that the priorities, however you signal them, or you don't signal them and you just decide, all of this is around about effective use or management of resources that are available. And those could be based on a transport, could be based on server, local, resources like CPU or memory, all of these other things. There's a whole bucket of stuff that you need to consider when you're operating client or server, and priorities can help you make better decisions, but it only really matters when there's a bottleneck or there's contention. If you have unlimited resource, you just send everything and you're going to work okay. There might be benefits to ordering certain things in front of others, but if you can run fast enough with enough throughput, you're probably okay. So the problem doesn't exist there. The problem exists where there's some form of bottleneck that makes you have to pick one before the other or drop one entirely before sending the other one. And in this case, like the deployment topology variations can mean you have a problem or you don't. So one example with HTTP priorities and some of the kind of lab testing that you have is that you're reading everything from a local file system and all of the information is there and you have all of these priority signals and you're able to kind of model the world and do the perfect solution. But in reality, sometimes you don't have those resources at all. So even if they're the highest priority from one perspective, you don't want to delay sending stuff because you've got the lowest priority at the other end. This is all just basic priority queue stuff. So it depends. And I think that's part of sometimes difficulty in understanding if there's a problem or not, is that it literally doesn't exist for some people, but for others it can. So the example, if you go to the next slide, would be to look at MASQUE and multiplexing and the potential bottlenecks that we have here. So kind of covered in some of the other slides already, so a nice warm up. Here we've got a MASQUE client speaking to a MASQUE proxy over one single quick connection. And that proxy then is speaking to multiple servers over multiple different layer 3 or layer 4 connections, because we're talking about connect UDP, connect IP. Next slide, please. So yeah, we have HTTP between the client and the proxy, and for just from the mask use case, layer 4, layer 3 to the servers behind it. Next slide, please. Next slide, please. Oh, yeah. And so if you're thinking about bottlenecks here, where's that kind of proxy going to be deployed, and where's the client going to be deployed? We've covered some of this already. Like, you know, you cover the client in an access network or using the access network to speak to a proxy, and the proxy is probably in a very well-connected data center somewhere. Not necessarily, you know, in the old school HP proxy use case, it was some box in your corp network before you even got into the internet. But in a deployment model where the proxy has great interconnectivity with all of these other servers that it's speaking to, it's probably less likely to have a bottleneck. Specifically, you know, throughput or congestion is potentially less likely to be happening there than the client and the proxy. Someone's going to argue with me probably in the chat that I'm wrong there, but just follow my story there. But also, like, the competition for resources is obvious, right? You've got one thing on the left-hand side with all the other stuff in it. And on the right-hand side, you've got independent arrows that they're competing, but in a different sense of level. And we talk about this with like multi-streaming and quick, you know, how many streams can you create? That's a resource. Flow control for streams, flow control for the connection, the congestion window of that connection. This is all, you know, multiple things that is, if you go to the next slide, the client knows the intent of these connections that it's creating, but the proxy doesn't know much. So we're talking about some of these extensions that can maybe communicate some of that intent for more optimization or whatever. But just again, just believe that the proxy is quite limited in knowing what to do. So next slide. We kind of already guessed that this could be a problem with TCP Connect, the old school Connect. So the RFC 9218 has some text there to say about, here's a good way to do stuff. Like, you don't want to get into a situation where you're whole blocking one stream because they're effectively all as important as each other, maybe. But they're not always as important, but effectively sharing some of that bandwidth is a decent strategy. It works pretty well. It's not the best, but it works pretty well. It's pretty easy to do. Next slide. So it works well for streams, but Connect UDP doesn't use streams. There's no formal means for the client to express the desired properties of how it would like the proxy to send datagrams to it. What works well, if you're in this model where you have a mix of Connect TCP, Connect UDP, maybe Connect IP, is kind of splicing these two different application data formats together, interleaving them, say, or bandwidth sharing, anything like that. And that can be implementation specific. You can just implement it. It's not hard, you just do it. But it's not clear if it suits the client's needs because the server's making up stuff effectively based on its view of the world, not necessarily the client's. And then sort of like a clearer problem statement is what I put there, that we have few tools to help communicate, help signal that some things maybe are more important than others in order to pick what's important there. Next slide, please. So we can solve this. This is what the draft tries to explain, that integrating an idea of datagram flows, which don't exist anymore, but they do because they're happening all the time, into the existing priority model that we have with HTTP. We can just piggyback on the existing connect and connect UDP methods and stick a header on and then just make it simpler, integrated. It's just a simple parameter. There's some basic guidance. You could ignore the signal. You could not put it there, but it's just nudging people in the direction to understand that this does occur if you've got multiplexing going on. And in my experience, because of the lack of flows at the quick transport layer for datagrams, some implementations tend to just have a single kind of output queue for these things, which is very, very different to the modeling of multiple streams and other stuff. So I think we could solve it, but the big question is, if you go to the next slide, do we need to? I think it's time to do something or do nothing. And I just want some input from the group because, yeah, I want to invest my energy in things people find useful.
Hi, Alex Shanovsky. Lucas, thank you for presenting this. My comment is quick. I feel that we have both Connect UDP and Connect IP on opposite ends of the spectrum here, where Connect UDP has payloads and then any bit you want to add is an extension, and Connect IP, which has all of the benefits of IP headers and our extensions are removing things for compression. This makes me feel that we're solving the wrong problem if we add this here. Shouldn't people who need this sort of stuff there maybe be using Connect IP? We have DSCP bits already.
I think the problem exists for Connect IP as well, because ultimately you're sending data grounds between the client and the proxy.
But what happens when you set a priority between the client and the proxy whose QoS bits have the inner packet mismatch? Like you created a new combinatorial explosion of like what happens when the client thinks the packet is unimportant on the client to proxy connection, but is super important for when it gets egressed.
That's a good question, and that's why I think we should probably provide some guidance to implementers on how to merge these things. And that's kind of where the HTTP priorities draft goes. It's like, here's a way that is easy and it will probably work okay, but you've got a signal there with QoS bits, but we lack the client intent. Like we need to help the proxy make some decisions, in my opinion.
Yeah, but yeah, I think we should be working on this. I mean, this is clearly useful, relevant. I mean, I can think of a number of simple use cases. I have a browser and some tab is in the foreground and I have a bunch of connections that are related to background tabs. And so why would I want them at the same priority as the foreground tabs, right? So like, I mean, they're really trivial to suggest use cases that seem quite easy to implement. So yeah, we should do something with this, but it is worth documenting things like QoS and other quirky issues that might arise.
Thanks. Martin? Oh, sorry.
Yeah, so I tend to think that when we have this continual problem when we talk about prioritization, where we sort of conflate the difference between applying prioritization based on the information you have and signaling it. And what you're talking about here is the case where the client wants to be able to inform the proxy for the packets that's coming back towards it, how to prioritize those things. And I think that's like, yeah, I think we should be doing that. There are mechanisms that we use that are very coarse that would work at the HTTP layer for something like MASQUE, but it would only sort of give you the ability to distinguish between different sessions, not to be able to at a finer grain level say things about how to distinguish, say for instance how to prioritize different datagrams. Like, I don't know how to solve that problem because the proxy is not going to be aware of the content of those things. So it leads me to sort of ask whether there's any need for some sort of signaling in some other way, for instance, passing on DSCP, as Alex sort of reminded me. That sort of thing makes me a little nervous, but I think if we have a sort of very crude mechanism here, that might be enough to get us a little bit more experience with what's going on. So doing something seems about right.
Okay, thank you. I think, sorry, we jumped Ben, who was in the queue accidentally.
Hi, Ben Schwartz. I still don't get why this is needed on a couple of levels. First of all, DSCP solves this for Connect UDP, because the direction you're concerned about is the downstream direction of a fast target running into a bottleneck to a slow client connection. And so DSCP bits sent by the target can tell the proxy how to prioritize those UDP packets that it's then going to forward to the client. So in the direction we care about, I think DSCP already handles it. And also, we have another solution for this already, which is that the client knows how much bandwidth is available between the client and the proxy. And there's end-to-end congestion control on all of those links that you indicated. So if the client knows that it's run into the congestion limit on the client proxy link, then it can choose how much of its congestion window it allocates among the different end-to-end flows that are sharing that congested link. So we already have two good solutions here. If nobody's using them, maybe they don't care that much. I don't know that we need a third solution.
So just a clarification question there, Ben. When you say the client knows the congestion window, from the server's perspective, it's its own congestion window that it needs to divide up into, I mean, 8 in my example, whatever. So maybe I'm missing that. We haven't got the time to discuss, but if I can take that.
The client controls how fast the targets send through the end-to-end congestion control on each of those end-to-end connections.
I'm not following,
So-
but let's chat more offline.
Okay.
I think I'm willing to have that discussion. I agree with your other points about the SEP. That was useful. Cheers.
Alan Frindell, I am a priority enthusiast. I think this is interesting work. I have a similar issue in web transport we're going to be talking about later today, which is what to do about streams that are hung off of a connect session. So it's very similar, I think, to defining how you prioritize datagrams that are hung off of a connect session. If you think about in web transport, there's a mapping over H2. I think similarly, if you're using these datagrams over capsules, they would inherit the priority specified by the connect stream. And I think that makes sense. But I think we haven't said enough about what to do about things that are hanging off of the connect stream and how to prioritize them. How to prioritize things within a connect stream. Say I've got different flows of datagrams and I want to prioritize them differently. That's a hard problem. Web transport probably has better mechanisms than ConnectGDP right now to specify those. And also as the mock co-chair, like this is also something that we know we're thinking about in mock as well.
Okay,
thanks.
Cool. And I didn't go into the technical details here, but like specifically, this isn't just a header. This is a signal that could be sent in capsules or other things. Like there's different ways we could do stuff. We could append it into the datagram, pay by register, and you can't. There's like loads of different ways we could do it. I need to go and speak to people to do stuff. So, cheers.
Kazuhoku, I could very well be incorrect, but I was just wondering if there's a reason to have a datagram, if there's a reason to have an urgency parameter specific to datagrams, where MASQUE says that it's an option to use a datagram rather than sending the data on the stream. So it's my understanding that the server can, it's up to the server's discretion whether it should be sending, whether it will be sending UDP packets over the stream or through the datagram packets. And then if they have different priorities, it seems strange to me.
Yeah, that's a great question. One of the motivating reasons is that you might want to prioritize the capsules on the control stream, like the connect stream that you have, because you need to send very important messages there, and that you just want to drop the datagram slightly so that you always keep up some free space for flushing stuff. That was the only reason, just flexibility. But if it's too much, we could change stuff. So thank you.
All right, with that, thanks, Lucas. And now we're on to the last section of the meeting, or the last topic of the meeting. Tommy or Ben, I don't know which of you intends to present. I assume Tommy, since he's in the room. We have a little over 15 minutes, which hopefully is good enough, so take it away.
All right. Ben, if you want to chime in at any point during the slides, please do that. I'll probably just try to blast through them and then mainly get input and discussion. So we don't have a document here. There was a document that Ben had previously talked about, but just wanted to have a discussion with you guys and see what we think might be useful, might be in scope, or might be useful and out of scope. Next slide, please. So why do we want to talk about configuration at all? It can be useful to know what a MASQUE proxy supports and details about how you can access different proxy resources. A client is going to need to know this information. This information can be sent out in a proprietary or a static manner. We can have well-known URIs for discovering and using particular paths on Connect UDP, Connect IP, or knowing that you support Connect. But there could be some interesting use cases for standardized configurations. And so unclear of how much, if any of this fits within the working group, but let's go to the next slide. So here are just some examples of the way that proxies can be configured. SOCKS proxies were just host names and ports, very similar for HTTP proxies. MASQUE proxies can have a template on them, and now essentially you get to the point where I may have a proxy that can do connect and connect UDP and connect IP, and those can all be separate templates. And so maybe you want to know how those are bundled. There's also interesting stuff that proxies do with pack files. And I think there's some things in there that are potentially relevant and may be important to know. Next slide. So this is a list Ben and I came up with, like all the range of possible things you could want to know. I think some of these are certainly out of scope, and we definitely don't want to do them or standardize them, and some of them may be in scope. So you may want to know, what does my proxy do? Like, do I have a proxy that can support connect UDP and connect IP, or is it just one of them? Can it support DNS proxying? There's also a question of, can you know ahead of time what types of things can you access through this? For example, split DNS, and I'll pull that out as a separate slide next. There's information about how do you want to authenticate. Some of that may just already be supported with normal HTTP authentication. Information about the entity running the proxy, things like, billing, et cetera. I imagine that's not in scope for this group, but maybe something that a client would want to know if you had some kind of open service of a proxy. Next slide. So one of the use cases which I think may be smaller and more tractable that we could point out is split DNS. And I know, Ben had said split DNS means different things for different people. I'm thinking here of what we do in like a VPN, where you have, we support this in IETF2. It also is very common in other VPNs where you say, this particular VPN is only applicable to this internal domain. And so you could also imagine that you have mask relays out there that are only applicable to access certain resources, and you're going to get errors if you try to talk to anything else. So if you have such a scenario, you could have different approaches. You could have kind of like the default, which would be at today, is a try and fail over. Like, I'm going to send every single host name I have to this proxy, and it will just tell me, nope, can't reach that one, can't reach that one, can't reach that one. And then maybe there's like one subdomain that it can reach. That's very, very inefficient and not ideal. We could have pack script support, or something like a pack script, where you run crazy JavaScript to figure out which names should be proxied or what things are allowed to go through this, but that is not ideal. We can have kind of static configuration where you have like a configuration profile or something hard-coded that is pushed onto the device out of band to say, hey, here's this proxy and this is what it supports. That works pretty well, and there are cases where we are using that approach. I think the problem where that breaks down is sometimes the configuration for what a backend relay may have for its routing of what domains it can access is more dynamic than what you would want for pushing a config update to every client that may be going through the service. If we think about the VPN type use case, it is great to not have to push a new profile update to everyone when you just add one subdomain. That's why a protocol like IETF2 can communicate the domains that it supports as you bring up the handshake. So we could imagine having something like a queryable resource on a relay where you, I don't know, it's some well-known or something that I can do a GET request, and it gives me a list of, hey, I'm going to allow you to access things in this list, and anything beyond this you can try to access, but I'm going to give you an error. And that would help clients out more dynamically. Next slide. So in the last 12 minutes, I'm just curious what people thought. Are there any aspects of this list of discovery or configuration that could or should be standardized? Which ones? Where should that be done? And within the charter that we're trying to approve, there is it says it's in scope to add things that are missing functionality and things that can ease deployability, but then policy and proper discovery is out of scope. So I would like to know, are things like knowing what domains can be accessed in like the split DNS model, is that something that's easing deployability to make it be more of a VPN replacement, or is that something we think needs to be done outside of this group? Go.
Hey, Tommy. David Skenazy, VPN enthusiast. For me, the answer to that question comes really down to what problem we're trying to solve. And what I mean by that is, so in a lot of VPN cases, and let's say you want to set up a VPN configuration and you need like certificates on both sides. The user's never going to type that in by hand, or X509 is great for that. So in those cases, you're going to have a file of some kind. Apple has a plist format, for example, for this. I forget what Android does. So in those cases, I don't think we need anything, because if you already have a format, and even it can be proprietary, you can add all these keys to that format.
So I think the one case I would bring up is something that's like more dynamic, like potentially the split domain list. So maybe that file says, I allow things under company.example, but on any given day, this proxy can only support internal.company.example or whatever, and that can change very frequently. And that is something that with VPNs, they are able to update and not have this configuration manageability problem. But if they were trying to use Mask instead, it could get very unwieldy.
Totally agree with you. And so,
another example. I want to jump in and say you mentioned that the sort of state of the art here is basically proprietary configuration file formats. And I'm okay with using a file format, but I don't think it should be proprietary. I think that we should try to figure out why people are using those proprietary formats and standardize.
That makes sense, but let me finish, because I think I'm overall completely agreeing with you two. Another example where this doesn't make sense is, let's say, one big deployment of Mask right now is Apple's private relay. No one's typing this in. You're getting a config bag that's dynamic and proprietary, and so you don't need a standardized way for that either, because at the end of the day, the way you pick your servers for this is based on contracts that people who aren't in this room are signing. However, there's still a wide range of things where this is useful. So if you look at both Android or iOS, and it's easy, I have both in my pocket, so I could just test this right now. Both allow you to add an IKV2 configuration, and you type in the server, you type in this username, and you type in the password. And that's something that a human can do. And for those, you need to be able to get everything else through the protocol. So I think my demarcation between where this is needed and where this is not needed is when it can be typed in, and the one you added where it's dynamic, just like in Connect IP we have the IP addresses and the routes. Adding the DNS makes sense to me as well, and that would be the split for me. So there's room to be done, and that's where I would draw the scope line.
Hi, Alex Chernohovsky. I guess I'm going to be agreeing with David, which I didn't entirely expect based on how that started. So I think specifically if we look at the VPN use case, I'm a little bit confused about the split horizon DNS examples that you were giving, because they don't match my mental model of the way VPNs are deployed. I mostly always think of them as VPN is either please suck up all of my traffic, in which case the domain allow list doesn't really matter, or you're connecting to a usually trusted network which is providing access to additional resources. And usually the way that DNS for that works is you usually are comfortable sending all of your queries there. And some of them, you end up getting back an answer which is wrong, and you can do it somewhere else, but that's something that we can decide we want to fix. And maybe I'm just out of touch of how VPNs, which do overlay stuff, work, but my understanding was there was not a lot of investment in making here a set of domains which are accessible over this additional overlay VPN, but please route all your traffic elsewhere, a high performance thing with DNS. So I almost feel like we're not entirely the right group to be doing DNS by ourselves if we're actually looking at some of these use cases. And I feel that we possibly need to better understand some actual deployments before committing to that. But I also totally think it's fine to have an extension that says, we're not going to give you a whole DNS server like you would announce with DHCP, but here is a set of domains that you can route through here, and here is a special purpose DNS server that is a stub resolver that will give you those answers. So I think that's fine.
Cool. So just to quickly respond to that, and like I'm thinking more here about the connect UDP cases where we're not doing DNS from the client. But for split VPNs, there are some cases where they scoop up all the DNS traffic and then they connect by IP address. But having implemented a lot of these libraries, a bunch of them do just like say, here are the names. Do not even they will not even resolve things that are not in the list of domains they access. And that is a very, very common deployment. And that's the deployment that we're trying to address here. And then also, I think particularly for the mask proxy case, when normally you would not have to do DNS in order to connect through, let's say you had like a bunch of different proxies and you want to know which ones to use for which, it is very inefficient if we would have to like do a connect request to the first proxy, see if that could support it. Nope. Now I tried my second proxy. Now I try my third proxy and just do like an exploratory search of like which of these like split proxies can actually handle my request without knowing it.
But is that a hypothetical? This would be slow, or is there actually a deployment model that we are aware
it
of
actually
uses
would be
multiple concurrent mask proxies like that?
Yes.
Okay.
Yeah, like cases where we today have multiple split VPNs where you could replace them with a mask proxy.
Great. I'd love to read more about that to motivate how we should solve this problem.
Eric Orth, Google. I'm still trying to collect my thoughts on whether or not I think this stuff should be standardized, but either way, I want to express the sentiment that I don't think this is the right working group for this, because maybe someone can correct me because I haven't read our recharter proposal in a while, but I believe the overall goal is for this group to stay focused on proxying UDP and IP and stuff like that, and not be the general proxying working group. And this seems like a much more general proxying problem to me. This is, if we had general proxying solutions for better standardized configuration and doing it by DNS, and we just said, hey, we just need to add in certain arguments to make it more specific to what we need for UDP and IP, then yeah, sure, we could do that in this group. But this is, we need to solve this more general proxying problem first, and big general proxying problems like this, I don't think this is the right working group for it. We need somewhere more general to work on it. Unfortunately, I don't have any direct suggestions for you other than not here.
Fair.
Eric Squirrel, without taking a position on whether we should do this or not, I do want to flag that it seems like there are at least two different categories of information here. And the way I would bucket them is information where it is the proxy's responsibility to tell you something and yours to believe it, and information where you do not trust the proxy to tell you something. So for instance, I would not trust the proxy. For instance, like I don't necessarily trust the proxy to tell me which domains that like it's allowed to capture, or IP address is allowed to capture, because maybe I don't want it to capture something even though it wants to, right? And so I think so either for I may want to send all my traffic to to Google over a proxy, but it's like also I could do Apple, but I didn't want that, and I wanted to send my Apple stuff directly. And so I think I guess I'd make 2 points. One is that in some cases that may mean having some way for the proxy to provide a tested piece of information to you. Another may be, which may be the case, or may be the case that there's so many things that have to be configured locally and to find some way to get that. So anyway, I'm not saying this is all infeasible. I just want to flag that there's multiple, that's not always the case. The proxy has to tell you things and you trust them.
Yeah, absolutely. And just to that point, this is the same thing that the IETF split DNS had to address. And the correct way to express the split DNS case is the proxy is telling you, these are the only things I'm willing to accept. You will have local policy about what you want to send to me. If you wanted to send everything to me, don't. It's merely scoping it down.
Agreed. And I think this also gets to sort of back a little bit this point David was making, which is a bunch of the configuration has to be fed in locally.
Yes. Yeah, absolutely.
I'm next. Martin Duke, Google, and with the AD hat on. So the current charter before the ISG specifically puts this out of scope. That said, it is not too late if there's like overwhelming desire to take this on. It doesn't sound like there is. I will take the action item to take this to the IESG. I think we should figure out where this is properly vetted. There's not exactly like overwhelming desire to standardize this, but I think there's enough interest here that this is a question worth having, so we can give you a good answer. And if whether it's a different working group or we BOF it or something, that's fine. So I will take ownership of that problem.
Thank you.
And give it to you. Thanks.
So Mike Bishop, thank you, Martin, because if I'm counting correctly, this is the third IETF where we've discussed this. And I think the general consensus comes around to this is a good framework. MASQUE has things that would plug into it, but we don't own the framework and nobody knows who would. And so I don't know if it needs to go to dispatch. I don't know if it needs its own short-term working group, something. But when the framework exists, I think plugging into it definitely belongs in this group. And I think there's value in the framework.
Cool. That's good. Thanks for the input. I agree with everyone.
All right. If there are no other questions, we'll wrap up here. Thank you, everyone. Enjoy the rest of the week.
Good idea.